Digital, please accept our thanks for being here today and sharing your time with us. We're excited to talk with you about how IDAS Digital is putting the power of AI directly in the hands of reliability engineers and asset management professionals. You're going to see something that's different than most other webinars that use AI and ML in the title. My name is Mark. I'm the asset management principal here at IDAS. I'm teamed up with my long-time colleague and friend, John Reddick, will be demonstrating this new and exciting capability. Say hello, John.
Hey, folks, everyone. Thanks for joining. Great to be with you. And excited to share this cool visual approach we've got to AI. Mark's going to kick us off here with a little bit of an introduction and I'll say level setting. And then I'm going to take it away with a demo, and we're going to walk you through this new capability from IDAS and share it with you, and greatly look forward to your feedback and questions as we go. Mark, back to you.
Indeed. Okay, so we've got some typical webinar logistics and housekeeping. Please don't leave with any unanswered questions, folks. If something pops into your mind afterward, we will have the chance to talk with you and after we send you access to the recording. And so with that, let's jump into the meat of what we want to show you here today. So perhaps we can start off then with what the analyst research has to say. The folks at LNS Research have given us a ranked list of challenges facing analytics initiatives, and as you can see here, the list that they've provided is more extensive than what you see here. But here are some of the more salient points that include such things as the first two, for instance, that point to data quality issues and gathering buy-in across the organization. These are examples of problems that have existed for a long time. The third point is the lack of collaboration, which is really more a symptom of misalignment. Stakeholder activities aren't sufficiently aligned and consistent with organizational objectives. And then the fourth point being end users aren't shown these capabilities and how they can help them do more of what they are good at. And so in response to that, the market hasn't been as helpful as it could be. There's a problem that most of the time you're being sold on the art of possible. In fact, marketing behind these solutions demands that you use your imagination rather than discernment. These offerings generally contain these silver bullets inside of black boxes that almost entirely focus on the computation itself. The solution being promoted might very well be something that you've had in place for years, for instance, vibration analysis, ultrasonics, thermography. And these may very well be just a repackaging of asset health monitoring with some type of AI-enabled anomaly detection. But most importantly, you need discernment to determine whether these promises are being made or actually make the solution seem more than it actually is. And so the team here at IDAS has several hundred years of collective experience working with the asset management community. And we know that part of your time is devoted to finding things that might help you within the constraints of your reality. What you've shared with us over the years and more recently, these solutions require a major system restructuring, a deep bench of data scientists, money, and patience for some of these big transformative AI-laced solutions. The second point is that problems that existed years ago still aren't solved, and you'll already have an abundance of data from sensors, and you'll still have functional silos that still exist. Third point being is your subject matter experts are already stretched really thin. You need to squeeze their heads and capture some of their knowledge and put it into a form that's accessible and scalable. And perhaps one of the most important realizations is that your system may not be set up to make use of machine or AI-generated predictions. And so along those years, you've told us that you're looking for specific things. And what you've told us are that you're looking for practical methods to detect anomalies within an asset strategy for all critical and significant equipment. you're looking for something that provides equipment experts with the ability to directly build their own models to identify emerging failure modes and identify when things are not good. And you don't want a black box. You're not interested in guessing. You want complete visibility of what the model is going to detect with support of visual patterns and simulation, validation. And most importantly, you're looking for something that will enable a work process with analytical outcomes to drive risk reduction activities and the sustainment of effective asset strategies.
And Mark, maybe I'll jump in here real quick and
Sure.
just a couple comments here, because these are critically important points, right? We've talked to a number of people in a variety of roles. The classic reliability engineers, folks that are managing monitoring centers. Oftentimes those are remote monitoring centers, and certainly the desire is there. There's the pressure there to look at AI and how AI can help streamline, reduce resource constraints that people have, how AI can make us smarter about what we know about our assets and that sort of thing. But it also represents some really unique challenges, like you've already pointed out. And what we're going to share today in this webinar, hopefully people will get the sense that we've listened to these concerns, these challenges, and the points that have been raised with us as we've developed this part of the solution.
Very good, very good. Thanks, John. And so as we move towards the demonstration of the product, one thing what we won't ask you to do today is to use your imagination. What you're about to see is something that's real, it's available, ready to be used, and our intent is to provide you with some actionable information, and you'll know one way or the other how this solution enables the plan, do, check, act cycle and enables a sustained impact on asset strategies. It'll show you something that fits into your plan for taking the next steps of incremental maturity in your asset management system. That this is a use case for AI in asset management, how AI is used to leverage human expertise to take information we have, to generate insights that we don't have, and then finally to achieve success without analytics experts and reduce your dependency on them, and to do so without dependence also on external third-party resources. And so what we'll ask you to look for as John gives you a tour and demonstration of this use case, there are several things we'll ask you to watch for. First thing is that how AI enables a model which uses direct, locally sourced input data, which isn't limited to just anomaly detection, but includes work history, process data, and multiple forms of condition monitoring. The other thing to watch for is how it's built around a training function that directly leverages the expertise of those who are most intimately know the behavior, care, and feeding of the assets that they're in charge of. The third thing to look for is this division of labor that it can achieve so that human experts can devote more time to things that they're good at and let machines do what they're good at. And then another thing to watch for is that the model can be validated via simulations. So the user immediately sees the results of the training so that they can have more confidence about its ability to make predictions in the wild. And then finally, we'll ask you to watch for how this all ties back to an effective strategy. When it's in place and working well, how does it help you to aggregate marginal improvements over time and compound the organization's knowledge of its assets and increase the quality of your decisions? And so I'm going to hand it over to John, but before he takes you to the demonstration, John, I've been talking to a lot of customers who are investing in reviewing and developing asset strategies, and they're expressing a couple of key challenges. First is around selecting and implementing the strategy itself. Second is figuring out where AI fits to support and sustain that strategy once it's been operationalized. And then perhaps the third challenge I'll just throw in myself is how then does this strategy help the asset managers do more of what they're good at? Like the first digital spreadsheet and how it provided the accountant the ability to see a moving picture of the business. How does AI enable the asset manager a more lucid perspective of the assets that they have care over.
So, Mark, let me, I'll flip over here to the demo, and folks, you know, what we plan to do is spend the majority of the time today in this webinar going through the product. And Mark, to your points you were just making, or kind of questions that you were asking, you know, how do we enable the asset management professional? How do we enable them to tap into AI, to tap into advanced analytics and, you know, the emerging AI space? But also, and probably this is as important, and maybe, you know, with my reliability background, I'll say more important, how does that fit into what we're doing today? You know, I talk to folks that sometimes are struggling to get the real value out of condition monitoring programs, to make sure that their PMs are accurate, or maybe they're even on the front end of that a little bit, and they're going through the process of defining and developing FMEAs and RCMs around their equipment and so forth. Those are real challenges. And so if we were to just layer AI on top of that, all we would do is create another silo. We would create another work stream for people to manage. Certainly there's going to be data or intelligence that comes out of that has to be managed. And so it would just compound the existing problems. So with our practical approach here at IDAS, I really hope you get the sense as I go through this, that we are tying this into the asset strategy, that it can be a piece of what you're doing today. It fits as a part of APM in general, but AI, application of AI is not APM. And so keep that in mind, I hope, as we go through this. And maybe what I said challenges or maybe generate some questions from you. I welcome those as we go through it. I'd love to have that dialogue. And so let me use that kind of as the backdrop and the beginning point with the demonstration. So here I'm sharing the application with you. We are looking at what we call a twin profile page. The twin profile page follows our work process where we define risk and understand risk associated with assets. In the IDAS terminology, that risk incorporates failure modes, and we apply protections to those failure modes. The protections safeguard the asset from the risk of failure. And then we actively monitor. As data comes into the system, we're evaluating the execution of PM activities. We are evaluating condition data, and now we're also applying AI to data that's coming in. And ultimately, what we're after is the act piece of it, which is have the application prescribe to me, automatically prescribe to me what I should do based upon all those inputs, that information, distill it down for me. So at the heart and, you know, the core, the center of it, if you will, is the asset strategy. And so let's take a look at that strategy and how AI fits into it. So here you see the model for those, you know, users that are on this webinar. You know this well, you know probably better than me, but folks that may not be users, you know, effectively what we have here is we have a FMEA or RCM model that's been put into the IDAS application. You can see the asset in the center represented by dark blue. You can see failure modes associated with that asset represented by these light blue circles. And then if we, you know, zoom in and maybe navigate around a little bit, you see the green circles, which represent those protections. And those protections fall into one of three buckets for us. Those buckets are an activity protection, whereby your PMs are going to be done. Those PMs, you know, are tasks that you're going to perform to maintain and ensure the assets operating status. Condition protections also fit into that. Condition protections would be pressures, temperatures, flows, vibrations, etc. You know, many of those. And you see examples of those here, right? And this one on the filter actually has both, right? You could be using a time-based approach where you're replacing the filter. You could be a more condition approach where you're monitoring the pressures across that filter and having that drive the change. And then I'll scroll around over here where we've got our bearing failure mode. And that's got the combination of all of this, as well as some of these AI approaches. So classic PM activity, we're going to lubricate this piece of equipment. Classic condition monitoring, we're going to evaluate vibration coming in on this piece of equipment. Other things like operator rounds are also represented here. And then this is an example I'll walk through with you today, which is deviating bearing temperatures. And this is an example of our pattern protection. And we're going to go through this example. We're going to set it up, see how it's set up, see how it's trained, see how we can simulate it, and so forth as we do. But what you see here, again, I'll highlight, this is the strategy for the asset. It is inclusive of all of those approaches in one. And we strongly feel here at IDAS that if you don't take that mindset, then you're going to create more problems. You're going to have challenges with data and so forth. So,
John, I'm just going to jump in here and have a quick commentary on what you just showed us. AI needs to be inextricably tied to the strategy. So it's not about the prediction itself, but what the prediction does to inform the strategy, because each of those bubbles that you showed, is potentially an inbound stream of information that, an AI model could make use of. So maybe you can comment a little bit about how all of this is tied specifically to a strategy.
Yeah, so the strategy is all encompassing. It should, in being all encompassing, should include all aspects of how you're managing that asset to the performance level that you want from it. And classic, fashion, PMs are a great way to do that. Condition monitoring is another great way to do that. And more recently, with the rapid expansion of cheap sensing technology, and therefore the data that comes from that, AI is becoming, I'll say, another tool in the toolbox to manage the asset, and therefore complements the strategy that you're using to manage that asset. And here on this screen, I'm on what we call the monitor page. I can see that I have the combination of condition protections. You see some of those at the top here, a bearing indicator that is a classic condition monitoring protection. I'll skip down here. I've already talked about lubrication as a PM type of protection. And this is where we're going to drill in a little bit more and focus on our pattern protections implementing AI. And this is a deviation in bearing temperatures. So let's take a look at this. Now, as we take a look at it, let me kind of explain, the data that we've got here, the data that we're seeing on the screen. And so this chart shows us the trend of these temperature values. This example takes into account an inboard and an outboard temperature value. And in my terminology, the way I like to describe it, I say these things should be in sync, or at least they should ride along, together. And when they don't, that deviation is an indication that you may have a problem with one or more, one of those bearings, because it's behaving differently than the other. These things are closely coupled. They're on the same machine. They should roughly be in sync. In the chart, we also see a couple of other things that are really helpful for us. Across the top, we've got these triangles. These triangles represent work that has been performed against this piece of equipment. And over here on the edge, I've got, a red one that indicates corrective work. So we can see, as we're looking at this pattern protection, when that work is being done, because that could be insightful for us as we're developing this pattern protection. Another thing that we see here is these shaded areas. These, in this case, they're red. Those red shaded areas represent where we are seeing the pattern be detected, where the pattern is emerging, might be another way to say that. And lastly, we've got these triangles, which represent where the application is initiating a piece of evidence or an advisory for us. That's automatic. It happens in the solution. And that's how the application talks to us and says, hey, I'm raising my hand. I want you to be aware. And you can see one example of an advisory down here for a visual inspection. We'll come back to this as we go through the demonstration in a few minutes. But this is the visualization of really the output. And many of the questions we get on AI and all are, well, how do you set it up? How do you make use of it? And that sort of thing. So I'm going to
So
walk you
John, what you
through.
just, yeah, sorry, John, what you just showed us was really, a view of how you can make some investigative observations on the part of the asset expert or team of experts, right? So leveraging what they know, such as maintenance history and failure events and maintenance events across a particular timeline, to generate and hopefully generate insights that you don't know. Perhaps you can elaborate just a little bit more. And I just want to clarify what you previously showed us wasn't, the functional capability of the AI itself. We're still getting to that, right?
Yeah, I mean, that's the results of it, the results of the AI. So what we're going to go through now is how did we generate that result? What do we need to do? What do we need to set up to create a model, to train a model, to validate a model, and that sort of thing. So that's where we're headed right now.
Great.
So I'm on the edit page, and I see that there's some questions that have come in. Folks, we're capturing these questions. We're going to have a Q&A period at the end. So I'll say stay tuned, and we'll get to those, or at least as many of those as we can. And also our plan is to follow up by email if there are questions we don't get to. So I'm on the edit page for this pattern protection. Notice the inputs here. You see those green items. This example would be tied into my process historian. Those would be tag values feeding me these inboard and outboard temperature bearings. Other sources of data certainly connected to IDAS flow into this same model. This is the example we're going through. I've deactivated this protection, which allows me to edit it. And I've got it set up so that it's going to look for a pattern of deviating bearing temperatures. And in the case that we find those, there's an advisory here that will be generated, and you see the template for that advisory. This is the automatic piece of it. So if the conditions are detected, the advisory is automatically generated. Now, let's take a look at how this really gets set up. And that is done through the train page. On the train page, as I go here, let's get into the details of this. I'm going to zoom out a little bit so you can see a little bit more data. I selected the training window button here, and when I do that, you see the bluish gray area that is shaded on my chart. You also see the work records represented on my chart. The purpose of the training window is I want to set a period of data or capture a period of data that I'm going to use to build my model. And then I should keep a period of data outside of that, which I'm going to use to test, validate, and what we call simulate my model. And so the training window sets the boundaries of the data I'm going to use to build my model. The next step is for me to select patterns. Think of patterns as ranges or specific parts of the data set, the training window, that I want to use to build that model. Now, here's the visual approach. So you can see these shaded areas represented in our model. The approach we have taken with development of this technology is to make it as graphical and intuitive for the user as possible. So I can select one and I can delete it, right? It takes it out of my model. I can also click this plus sign and simply drag and drop if that's an area that I want to include in my model. I can take an existing pattern, I'll grab this bigger one, and I can slide it, adjust it, however I need it to be to, I'll say, get it right, to get it tuned. And once I've gone through that visual process of selecting those data ranges, the next step I need to do is train my model. And so, well, I got ahead of myself. I need to save the changes that I made, and then I can train my model. And so I'm going to kick off the training process here, and this will run through. And maybe, I'm going to do things like this for our demo today. Maybe this is not the best approach for a webinar because I'm creating dead space and I'm going to have to talk through this. But this is the real world, right? This is what you as a user are going to be doing. So it took 7 seconds or so to train. And so, Mark, real quick, let me just say what I did is I made changes to the data I wanted to train the model on, deleted, added, changed those ranges, and then I trained it. So I now have a model that is built and is behind the scenes, if you will, inside the application. Mark, were you going to make a
Right.
comment?
Yeah, so selecting that training window, that interval of the data that you're interested in, right? And it's multiple variables of data. Then you're selecting a particular pattern that you want to train the model in. So your input data, your training data, and I think you're about to show us the feedback data. But what I want to emphasize here is that you've just shown how a model could be constructed by an expert user, make the use of locally sourced input data. That is, you're not having to send this data off site to some sort of external expert or to some runtime environment that you don't own, right? You know exactly what's being processed and what models being used.
That's right. And look, I'm the expert in here. I'm the one in the driver's seat, right? So maybe we don't have an expert involved.
Uh-huh.
The other thing is, like, the subject matter experts, they're the folks that know the assets. They're the ones that have the understanding of the equipment. So I don't have a data scientist sitting with me today. I don't have somebody writing code sitting here next to me, and I'm not telling them what to do and how to do it, right? I'm able to do this myself. And it's critically important that as I do that myself, I need to validate it, right? I made some changes to my model. And so the simulation I'd run previously was out of date. I'm going to kick off another simulation here in this process, again, creating one of those dead spaces in our webinar that I've got to talk to. But let me explain what's going on here. You saw me pick the ranges for the training window. You saw me manipulate and work with the patterns themselves, the areas in the data that I said, hey, AI, I want you to look for these types of things. And now what I'm doing is saying, okay, AI, if you're looking for those types of things, what would you do with my historical data? And so you can see here, what I'm doing is I'm running a simulation back to 2022. The model that I just trained in front of you today was just executed against my historical data. And I'm going to zoom out here a little bit and pull some more in. And you can see, you know, I've got these shaded areas that are in there. And, you know, it's detected based upon the patterns that I picked, right? And down here, I've got a nice summary that tells me, hey, you know, we detected 14 occurrences of these deviating conditions and so forth. And, you know, we can drill in and look in any of these. And, you know, here's one right there you can see on the screen. So the value of the simulation is I train the model. I then can use all of the data. I can test the model. And you know, if it's not right, if the results that I'm getting here are not what I was expecting, and I'm navigating around and looking at it, you know what I do? I go right back here to the train page, and I have complete control over making changes to these pattern ranges, to the training window, and adjusting the model. And yes, it might be an iterative process to go through training and simulation. But again, the resources are me. I'm the expert. I know the equipment. I'm not dependent upon others to make this happen. And I'm able to do this in a visual manner, looking at the data, looking at the characteristics of the piece of equipment and that sort of thing.
So one of the risks that I think that are associated with analytics and machine generated predictions is that my inbox may be flooded then with all of these alerts that previously didn't exist. And so you have to spend a great deal of time chasing ghosts, if you will, or, you know, or selecting the alarms that are really the ones that, or the advisories that are really the ones that matter. So what you've just shown here is that a model can be tested and tuned before being put into practice, right? So you have your input data, which is your historical data, you have your training data, which is your expert insight, and then you have the feedback data. So you know the model, the data you've run through it, and you've tested it against known events, and in such a way that you've been able to see how well you predicted the past, right, John?
Yeah, I'm validating on the actual data from this piece of equipment. I think that's the way to say it, which is incredibly important and valuable. And the other thing I'll say, you know, to your comment about you spamming, spamming, right? I've got a summary down here that can look and say, like, you know, hey, if 14 advisories over this time period is not appropriate, I got a quick summary that gives me that indication. And, I could set up notifications on that. I could also set up excursions. And, again, I get the information I need to validate, hey, is this thing going to deliver for me? Is it going to deliver uh, based upon the historical data? Is it going to deliver the insights and intelligence that I want out of the model itself?
Right. So, I mean, the main takeaway here is that you want to have confidence that you can train this AI model, so you feel confident about releasing it into the wild, as it were.
Yeah, great way of putting it. Yep, good point. So I'm going to flip back to the monitor page. This is where we had all of our protections listed out. And earlier, Mark made a comment to this concept of folks we've worked with and some of the challenges that they were sharing with us. And one of the things that we heard over and over again is, I want to take advantage of AI. I think it's got real potential, and it does. I think it can help me and my organization better manage my assets. But you know what? I don't feel like I'm at a point where I can define specific anomalies, or maybe I don't have the data to select specific anomalies and that sort of thing. And so much of AI and the noise in the marketplace today is around anomaly detection. And that's because people are trying to find, those specific problems. And it actually highlights one of the issues that I have and others have around AI, is that you can go through that process of evaluating the data, reviewing the data, building a model, coding it all up, and so forth. But at the end of the day, you've solved a very singular problem. So to that, and based upon the feedback that we've heard, I want to walk through this example here, which is kind of the inverse of what I was just doing. I will often refer to it as the good condition. Here I've got it described as the expected conditions. So let's take a look at this one, and I'll explain what I mean. If I'm not sure that I've got data to support anomaly detection or can identify anomalies, I might have data that tells me what is good or what I expect out of my piece of equipment. And so again, I'm going to zoom out. I'll pull in a bunch more data here for us to kind of get a sense and look at. And as I do that, you'll see these green shaded areas. These green shaded areas represent what are expected operating conditions for this piece of equipment. And if you look at where I put those green shaded areas in, and I earlier characterized it as kind of the inverse, it's where those bearing temperatures are roughly in the neighborhood of 150 or so degrees. They are roughly riding along with each other as I would expect them to, and so forth. So that's what I want out of my piece of equipment. That's the behavior I hope for. That's the behavior that is expected. And so this AI model is set up to tell me, hey, if you get outside of those expected conditions, raise your hand, let me know, and let me make an evaluation of what that might mean. So how is this one set up? Let's take a look at the edit page. So here I've trained the model and set up a trigger around expected bearing conditions. And I've also got this one where if I have a no match, meaning if the data being evaluated doesn't fall into that bucket of expected bearing conditions, it's going to fall into this bucket of no match. And we're going to generate an advisory for that. And this is a little bit of a different advisory. You can see it on your screen. I'll read it to you. This advisory is for, hey, asset manager, reliability engineer, owner of the model, whoever it might be, have a look at your data. Have a look at your pattern data. Why? Because you've accumulated 30 days of unclassified pattern data, and you may now have the opportunity to either classify another pattern, which could be an anomaly, or maybe you need to look at that 30 days worth of data and you can add it into your existing pattern that you define, and you can improve your model or extend your model or tune it better, whatever the case may be. So this we feel is really important, and it's again directly based upon feedback that we got of, hey, just let me know when something goes bump in the night, when something's going awry, or maybe I need to take a look at it. So that's what's going on here. Again, I'll flip over to the train page. And on the train page, we're going to see the same types of things. I have the same capability where, I can manipulate my patterns and change them and all that kind of thing in a drag and drop fashion. I can run through the training after I save. I seem to forget to save. And so I can run through that training when I go through that approach. And then again, I've got the simulation capability here that I can run through. And notice it's smart enough here to call out, hey, you made some changes, right? And you didn't train it. So now you need to go back and train your data. So this is, we feel like maybe a way to start into AI by training on expected conditions. With the training on those expected conditions, you can go through the simulation process, validate it, and so forth, and then have IDAS sit there in the background, monitoring your asset. And if something deviates from that or is different from that, let me know. And that's exactly what this does.
So, John, I think it's important to point out that there's a vital difference between diagnosing and detecting. So when you're looking at an AI-enabled point solution that's optimized for detecting a particular anomaly, that's one thing. But I think what you've just shown us here is the opportunity to classify data based on a deviation of what good looks like, and have the application to invite the expert into potentially diagnosing an undefined problem, or a problem that may not have the resolution that they wanted to, but now they can go down that path and apply their expertise accordingly.
Yeah, undefined problem or unknown issue, right? All of those kind of fall into that bucket. Absolutely.
So the model can self-monitor.
Yes.
It can advise when there might be enough data to create a new classification set or expand on the training. So the SME then can spend valuable time responding to what the model has highlighted rather than searching through data and sifting through exception reports.
Yep, absolutely. And so let's talk about the output, because the output of this is just as important as everything else that I've taken us through. So I'm going to go back to that first case that we started on. That was those deviating bearing temperatures. And remember, before this advisory that I called out, I want to go to this advisory and I want to kind of walk everyone through, what is this advisory? What is it telling me? What is it doing, and what is its purpose? So I've opened it up here on the screen, and across the top, you've got some header information. Notice that this one's submitted. I'll talk about that in just a second. From my reliability background, I love the fact that this thing is tied to specific failure modes. Another way to say that is, this is the failure risk that this advisory is calling to my attention. And you see those listed there. It's got a priority. It's got a target date associated with it as well. And lastly, there are individuals or a team of individuals that are part of the reviewers here. And this allows us, folks, to collaborate on this, to give our insights. And, Mark, I can add you in here and save it. And now you're going to be one of my reviewers, and you can collaborate with me and the rest of the review team on this advisory. But let me scroll down, right? There's a lot more information here. And as I scroll down, I'm effectively going back in time, and I'll go part of the way down. So one of the things that AI gets dinged with a lot is false positives and raising the flag all the time. And you see I've got a combination of things here. So we had cases where we've detected early on deviation in bearing temperatures. The important thing here is that it is coupled with and combined into this advisory. It is bringing all this insight together. Remember earlier I was talking about AI is not APM. API is a component or an adder to APM. And APM consists of condition monitoring, consists of PMs and so forth. So notice here, my AI detected a deviation. We also at the same time got an exception because we went outside of expected conditions. Also in here, I've got some other cases where our condition monitoring now starts to kick in, and our condition monitoring is telling us, hey, you've got, something going on that I'm seeing and detecting in this as well. And also note that I've got a variety of users collaborating, adding their comments, putting their insights in here. So we're building up not only a collaborated or validated story, but we're pulling together the expertise of the folks on our team and able to go through that process. And as I scroll through up, you see additional evidence that's been added here. I have all this available to me as a user. I can see that again to validate the story. And ultimately, what happened here is Jake, he went in and he generated the work request for that. Think notification inside of SAP, work request inside of Maximo, or work order maybe in your system. And I've got a direct link to that work request that was generated that allows me to directly navigate to Maximo, to directly navigate to SAP and see that. And that creates a very tight coupling between all the information I've got here that led me to that decision and the ultimate resolution that will be associated with the work order that takes place. So again, to reiterate, the AI is complementing our existing condition monitoring. It's complementing our existing PMs. It's adding additional evidence and validation around what's going on with the asset. It gives me a single place to go to see all of that together. So the advisory is really where it comes together at the end and is critically important to the work process. Now, the last
John,
thing
as
that
you make those,
Yep,
sorry,
go
John,
ahead.
as you make those points, I just want to touch on this idea of division of labor, right? So again, the corollary is let machines do what they're good at and humans do what they're good at. And this whole idea of the division of labor is that what you've just shown us, this capability not only allows you to more incisively detect failures in progress, that is, that anomaly detection is there, but it also can be trained to look for things that deviate from what good is, and then supports also a diagnostic workflow, and then gathers all of the necessary expertise, again, for humans to do what they're good at, to collaborate on not only what's being detected, but what they can potentially diagnose from these deviations from what good looks like.
Yep, yep. That's all in
Very
the
good.
hands, the hands of the user.
So
Um,
maybe you can tie this off by talking about, well, this is all really great on this one specific case, and the pump review team and what have you. Can you maybe talk a little bit about how you can scale this effort?
yeah, so that's a uh, critically important, and I think when we talk about AI somewhat complicates that for many folks. I talked earlier about singular solution, very specific failure mode, and so much of the talk now is around anomaly detection. So as I've already described, as I've already shown you, the model that exists behind this twin that we've got on this page. We've briefly looked at condition monitoring as an approach. We've looked at some of the PMs as an approach, and I've in more depth gone through AI as an adder to that. So, part of the IDA solution is how do we scale? How do we operationalize the asset strategy? And how do we do that quickly and efficiently? Our users know well. For those of you that aren't users yet, I'll say there's a library embedded in our application. And so I can take this model in its entirety, everything that I've shared with you, everything that I've tweaked and changed and saved, I can take that and create a twin model, put it into our library. And so we see that same model here. I do have the ability to filter, so I could drop out failure modes or protections if I wanted to when I create this model. And I just need to give it a name. I'll call it IDIS webinar. I'd fill in a description. I'm not going to make you watch me type that. I can be specific and describe a manufacturer that this might be associated with. I can describe a model number that it might be associated with, use my category, class, and type values, and then I can create that model and put it into the IDIS library. And now what I have is my best practice, my standardization, my consistency. Everything you saw me build, touch, edit, save is now in this model, and I can go through the process of applying that to 1, 5, 100, 1,000 different assets. The more common scenario is I've got this model created. I want to use it as my best practice. I may have, let's say, a skid that I have like equipment across, multiple of these skids, or maybe I've got a bank of pumps, and I want to apply what I just did to not just one of those pumps, but let's say 5 of them. And so having this model in the library makes it very easy for me to be able to do that and to scale that. So again, it's about promoting the best practice and about operationalizing the asset strategy.
I think
Mark,
as we wrap this up, we might have opportunity now to flip back to the slides and then dig into some of these questions that have been posted. I think there's a really great quote here that I think we can finish off with from the world of academia. It says, "Artificial intelligence does not actually bring us intelligence, but instead a critical component of intelligence, which is in fact prediction." I think, John, you did a really great job of demonstrating that in the new IDAS capability here today. There's a number of key takeaways, and then we'll just jump into the questions here. AI is here to stay. Obviously, it's a very good thing. When I turned, just into my double-digit years, 1 gigabyte of storage costs $300,000, right? So current economics definitely certainly favor artificial intelligence, and so we're living in a time where we can take advantage of that. Second is, with a more optimal division of labor between your own human experience and artificial intelligence, you can reduce the dependence on external services and resources and runtime environments that you don't own. On that same note, putting the power of AI into the hands of your asset managers reduces your dependence on internal expert resources and technical specialists, say in IT or what have you. And then it gives you the ability to squeeze the heads of your experts, that is, capture that knowledge and bottle it and bring scale to that knowledge by training the model and enriching the library over time, be able to scale that knowledge across numerous assets and asset systems. And then finally, bringing all this back to the strategy, which determines everything that goes into safely maximizing predictable production at the lowest sustainable cost while observing the risk profile of the business. And you recall each of those bubbles, each of those protections are meant to enable the success of that strategy. And this visual AI anomaly detection capability is part of a complete breakfast, if you will, part of that successful strategy once it's operationalized. And so perhaps we'll dig into questions now. There have been a number of questions that have been submitted via the questions panel. Perhaps,
Mark,
John, what we can...
Yeah, I'll go ahead and start out here, maybe.
Sure.
And folks, we're not going to be able to get through all these, so know that we'll follow up with you afterwards, and we'll pick a couple out and roll with these. There's a question submitted by Neil around, is there an assessment that is done if AI is necessary in a business? And Neil, I think that's a fabulous question, and it's an interesting one. Maybe I'm not going to answer it specifically with an assessment, but I'll give you a couple nuggets of my thoughts, and would love to catch up with you more. So one of the challenges or problems I think people are especially, well, I'll just say this: people are saying AI is going to solve all the problems, and I don't believe in that. And I think there's some problems that AI should not be applied to, at least at this day and age. And what I mean by that is lower criticality equipment may not fit into that bucket. You may not have the data to support it. Sensors are changing that, but maybe not have changed it in your organization. The other thing I would say is, do not think you can leap over some of the reliability funnels of good PM practices and condition monitoring and save the day with AI. I am firmly rooted and believe in fundamentals of reliability, and they deliver tremendous value. And in many organizations, that value is not fully unlocked yet today. So I'll share that as kind of an answer to that question. And again,
John, maybe if you'll allow me to pile on to that answer, an assessment done for AI, I think from my asset management standards background, the ISO 55001 standard, there's a great deal of room for discussion around how AI can be applied and done so successfully as part of an asset management system, where the point solutions might fit, where the applications might fit, but more importantly, how can AI enable the successful interactions and elements of an asset management system working together. Perhaps maybe taking a very specific question and providing a pretty high-level answer, but I think one of those areas that you can look to as a strategic asset management plan, as described by the ISO 55001 standard, is a way of doing that assessment. John, maybe I'll get you to flip to the next slide as we go through the rest of the questions. We've got a number of QR codes that you have access to here. There's a number, of course, John and I can be reached on LinkedIn if you wish to contact us, and let's spend a few minutes together to perhaps answer some of the unanswered questions. Something might pop into your mind after the end of this webinar. And there's also QR codes down along the bottom there for what we believe is very useful information on our blog site and on the IDAS Digital Insights page. And so, John, I'll let you pick the next question.
Great. And I'll just say, look, my email address is there. My email address is there so that I can connect with folks like you. I love industry perspective and the real world perspective that I get as I work with folks and interview folks about, hey, what should IDAS be working on and doing next? So reach out to me, send me an email. I will follow up with you and chat with you and look forward to doing that. Mark, to the questions. So there's a couple questions here, and I'm going to group them together a bit around fixed equipment, and I'm generalizing here, so bear with me. Fixed equipment, and how do you do models around that and failure modes and so forth. So yes, I went through a rotating equipment example today, but there's nothing to say that the exact same approach and techniques that I used here cannot be used for fixed equipment. And I'll also expand on that and say these exact same techniques can be used from a process twin perspective if you want to model and look at process variables or larger groupings of pieces of equipment and so forth. So while I did go through that rotating example, really any asset and really any data source can be included in this and used by what I've just described, the exact same process and visual techniques. And if you want, more specifics around fixed equipment and so forth, again, reach out, and I'd love to have those conversations. Mark, I'll flip to you for a question.
There is a couple of questions here around using this for low criticality equipment, and I think that might, might have broader implications in terms of how do you decide what's critical and what's not critical. Can you expand a little bit, or maybe shed some light on how some of the below radar assets might be applied?
Sure. So sensors are getting cheaper. Data storage is getting cheaper. All of that is driving this AI storm, if you will. And it also means that more assets could have more advanced techniques applied to them. And that just means more for folks like yourselves to manage. So yes, to answer directly, everything I've showed you could be applied to lower criticality equipment if that makes sense for your strategy. And that's probably the important question there. Historically, what we see is the more critical, the larger, more complex assets have more sensors and therefore more advanced techniques or monitoring approaches applied to them. In some cases, those are third party or contracts where the manufacturer provides a monitoring service and so forth. We, IDAS Digital, feel that by enabling I'll say the reliability community to visually apply AI to their assets and to their data, we then provide the ability to extend down that criticality Pareto chart or curve or however you want to describe it, and get to more assets with more advanced techniques. And feel like that really can unlock and reach into some, to this point, untapped potential. I hope that covers and answers the question. Again, happy to discuss further offline with folks.
We got time for maybe one or two questions here. One of these, I'm not exactly sure when the question was written, and it might have been answered, but I think it's worth revisiting. What are you doing to reduce false positives?
Yeah, so I'll just highlight a couple of capabilities that I showed in the demo. First and foremost, the ability of the expert to create the model does a lot up front. The ability of that same person to then, after they've trained it, to simulate it and basically say, what if this model had been in place, what would it do? That is a great indication of what it's going to do, you know, as new data comes in. That's a tremendously powerful tool for false positive reduction. We call that tuning in our words. The other thing is, you know, in that advisory, I scrolled down, I went back in time, and you saw that there were a number of occurrences of different inputs, right? The expected model had an input, the deviation had an input, but you also note it was encapsulated into that single advisory and grouped in that single advisory, which again provides a great way of, I'm not managing those things individually, I'm managing them more holistically and together as a group, also combined with my condition monitoring inputs, combined with my PM execution inputs and so forth. So by bringing it all together, that allows you to have a better filter of false positives. And then lastly, I'll say always being able to go back and to tweak, tune, change the model and run it through the process I've already described, I feel like is a great way to deal with false positives and help out with that.
All right. Very good. Last question. I want to ask this question because I think it's a very good one. Because I think a lot of what we demonstrate today in today's use case is around condition data. So the question is, what about anomalies for process variables? A lot of the solutions that you see out there say, all you need is our solution, and then we can help you change your world entirely, including process optimization and carbon footprint and manufacturing optimization and all of those types of things. So perhaps we can bring this use case back to, is it just for condition data, or what can you do with process variables?
Yeah, I mean, realistically, I think you could apply just about any data. From a reliability perspective, certainly process data fits into that. And you can evaluate the process going on with your manufacturing or your facility. So the short answer is yes, certainly can be applied to process data. And it doesn't change. The steps I went through are the exact same. And oftentimes with that process data, that looking for if it deviates from expected behavior is really valuable, because then you can start to fine tune and I'll say nail down where you might have those process upsets, deviations, changes, etc.
So if my line has more frequent stoppages than I thought I was having, or more frequent slowdowns, then that could be a deviation of what good looks like then.
Yep, certainly.
Okay. All right, that takes us to time here. John, thank you so much for a really great, insightful demonstration. Most of all, though, I'd like to thank the audience for hanging with us. We really appreciate you sharing time with us today, but I'll urge you as well, and remind you, please don't leave any questions unanswered reach out to John for all of the hard questions, and reach out to myself for anything else that you might be interested in. So we look forward to talking with you further about this down the road. And thanks everyone for your time and interest.
Thanks, everyone. We'll see you.